Hey guys, this is the topographic maps or topoMaps, the basics for notes just in case you missed it and or you need some review before the test. So looking at this first little piece, remember the vocab in this unit gets pretty twisted because it repeats a lot of the contour this and contour that. So the first word is contour line. And this is a imaginary line that connects points of equal elevation or height on a specific map. So if you look at the top picture, we have a small hill, and then if you were to walk the base, the circumference of that hill, it is 200 meters above sea level. So that's why it's marked with a 200. And if you walked up 25 meters, and then walked the exact same circumference, then you would be walking 225 meters above sea level. So that's why the 225 meters are marked. Which takes us to contour interval. Contour interval is the change in elevation between the lines. So this is what do each of the lines count by, or what do they go down by. In the hill, it goes by 25. So it's 200 is the first line marked, and then it goes up 25 more feet, and then they mark another line. They go up 25 more, meters, and then they mark another line. If you look on the hill, there is a little X and a dot. That X and dot indicate that it is exactly 25 meters higher than the previous or contour line beforehand. If you look over to the right, it almost looks like the same top picture, except there's these little hash marks. These hash marks tell or indicate that it is decreasing in elevation or height. So that's what they call a depression contour line. And these are contour lines that show a decline in elevation. It could be like this one where it's kind of like a little ditch, or a valley even, or even a cave. So let's look at the next slide. These are mistakes that are made in topographic map designs. So if we look at letter A matches up with number 4, that contour lines never split or branch. If you look in the bottom left-hand corner, it looks kind of like a football goal. That doesn't happen in topographic map design. They are not allowed to split off or branch off. So that's part of that one's mistake. Letter B says it matches up with number 1, that all points along the same contour line are at the same elevation. And the lines in letter B are correct, that they're one single line. But if you look at the index line, the one that has the actual numbers on it, it has 1,400 and then 1,300, and that's just impossible. Choice C, or letter C, box C, has a problem kind of in the upper middle part on the left-hand side, and that matches up with number 3, that contour lines can never cross each other. They can't intersect each other because that's not how the land works. These are just laws and rules that go with topographic map creation. And then, of course, letter D matches with number 2, that contour lines eventually connect to themselves, as well as number 3, that they cross each other. So if you look at the index line of 250, it does not connect to itself. And then the line right below it actually has a little hook in it, so it does not connect back to itself. And then the line above the 250 index line crosses another line. So there's multiple mistakes in choice D. The index contour that I spoke of before is the contour line that actually shows the elevation. It's the number. In both of the maps above in the picture, all of the lines have an index contour. They have an actual number on them. However, we go back to the mistaked lines. If you look at choice B and pretend that both numbers are 1,300, the contour lines are just the light colored lines, whereas the index contour is actually the darker, kind of bolded colored line, and it has numbers on it. So if you can remember, the index contour is an actual number on that line. So in the picture, the index contours would be 25, 50, 75, 100, and 125. The relief is the difference in elevation between the highest point and the lowest point on a landscape. So in the little island in the picture, you would take 125, this is my dyslexia, 125 meters in its height, because that's the highest actual contour line that it's given, index contour that it's given, and subtract it from 0 because it is at sea level. We get a relief of 125 meters. There's a difference between sea level and the highest elevation marked of 125 meters. This one's got some different colors in it. I changed it from when we took notes to hopefully help people understand a little bit. Contours that form close lines are usually hills or mountains. The depression marks on this map, if you look at the green arrow, the depression is marked with the hatch marks, the little kind of teeth marks. So that shows a decline in elevation. The increase in elevation, when the lines are really close, if you look where the arrows are, this indicates that the hill or the mountain, its elevation and height increases very quickly from point to point. When the contour lines are together, but they're kind of farther apart than other locations, that's when you get flatter terrain. So if you look at the blue lines, like where the number 2 is, that area would be an area of flatter land or less steep. You could probably walk it pretty easy. Elevation, if you don't know, is the height of the location. It's usually in reference to a fixed location, and it's always above sea level, because we don't usually do elevation below sea level, then we just do distance below sea level. So elevation has to do with how high off of the sea level mark it is. Gradient, this was kind of confusing to some people. Gradient is the slope of a surface. So you can estimate or calculate by comparing two contour lines and then calculating the difference between those 2 points. And you would divide by 2 because that's how many reference points you're using usually, and that gives you the gradient in meters. So if you look at above in the picture, the red line is marking an elevation of 270 meters. But to find gradient of a location, you wouldn't find necessarily the gradient of an entire mountain or an entire hill. You usually just focus on a position. So if I'm trying to figure out what the gradient is between 260 meters and then the next contour line, which is 230, I would take 260 minus 230 and then divide by 2, giving me 15 meters. So there's a difference of 15 meters between those two locations. You could do it from the point in the map on the left. If you look where the X is, that would probably be a 300 because it seems to be increasing by 10. So 300, and then I want to subtract it from where the riverbed is. So that's probably close to 230 meters. That gives me a difference of 70, so I divide it by 2 because I'm actually comparing two different positions. So that gradient is a gradient difference, a slow change difference of 35 meters over time. So I hope this helps us. Then a couple questions. There's 3 slides left, and they're going to be question slides. So if I were to walk from point A to point B, what is the estimated distance that I would have walked? If you take a ruler or a pencil and you find the scale at the bottom, so in the picture, one of these little centimeters, and there seems to be 2 here in this picture, and I compare it with the top, because 1 centimeter is equal to 60 meters. I have 2 centimeters in distance, so 2 times 60 would give me 120 meters. So that would be the estimated distance that I would have walked from those positions. What is the possible elevation of point C? Because there's no X next to C, I know that it's not quite 90. So it could be anywhere from like 82 to 89 because I'm trying to not it's an estimated because I don't have a side view of it with how tall it actually would go up. The gradient from the top contour line, which would be 80, to the index contour line, which would be 50. So I take 80 and I subtract 50 from it. I get 30 meters. I divide 30 by 2 because that's my two comparisons. So I have a gradient from the very top of this hill to the contour line of 50, contour index line of 50. I have a 15 meter distance between each of those positions. Looking at the slide, I just said like 80 times, I'm sorry. Would it be harder to hike up Blue Mountain or Gray Mountain? So if I look at their index lines and I compare their proximity, like how close are they? Gray Mountain's lines are much closer together than Blue Mountain. So I would say that Gray Mountain would be a more difficult hike because the lines would be steeper because they're closer. The incline would be steeper because the lines are closer together. The second question is, if rainfall increased, what would happen to Carver Creek? And how does this affect the gradation of the mountain? So Carver Creek is in Gray Mountain. If the rainfall increases, I would get more weathering and erosion that would occur. And by more weathering and erosion occurring, my gradation would increase. My difference between the two distances would get more intense. Last one, what is the contour interval? So what does it count by? And if I look at the index contours, I have 30, a line, and 90. So an easy way to figure that out is to take 90 and subtract 30, divide by 2, gives me a 30. So each line is going to increase by 30 meters. Then which mountain has the highest elevation if you compare the numbers? Mountain A, the contour index is clearly marked on the second from the top line from the mountain. However, if you look at Mountain B, it's a little fuzzier. It seems that the 2 of 210 is marked on the third from the top ring. So you could argue that Mountain B is possibly bigger, but because it's not as clear, you would have a hard time getting this one right, I'm sorry to say. The third question, is the east slope or west slope of Mountain B steeper? So you find Mountain B, you look at the compass around the picture. East would be on the right-hand side, west would be on the left-hand side. Because the lines are closer together on the eastern side, that would make the eastern slope more steep, whereas the western slope would be more gradual. The scale of the map is located at the bottom where the little south symbol is, and the scale is 1 centimeter for every 1 centimeter on the map is actually equivalent or equal to 60 meters traveled. So hopefully this helps. If you have questions, please get in touch with me.